Okay, in this video tutorial, I will discuss on how to configure spanning tree protocol on the port-based VLAN Cisco switches. The switch can either use the per VLAN spanning tree plus, which based on the IEEE 8021D, or rapid per VLAN spanning tree plus protocol based on the IEEE 8021W. If you see here on my note, I have a note. You can see that this is the regular per VLAN spanning tree plus, and then I have the rapid one. Okay, I will make this note available to you via Blackboard, so you may have access my note here. The next one is STP is a layer 2 link management protocol that provides path redundancy while preventing loops in the networks. The algorithm calculates the best loop-free path through a switch layer 2 network by assigning role to each port base on the active topologies. Okay, and there are different kind of spanning tree interface states or role. Okay, so let me refer you to this one. I will show you my link here. I will make this link available to the student through Blackboard. I obtained this information from Cisco Catalyst 2960 and 2960S. If I scroll it down, the first state is root port. The first role is a root port. What is a root port? It's a forwarding port that elected for the spanning tree topology. And then you have a designated port. Designated port is a forwarding port that is elected for every switch LAN segment. Okay. And then you have an alternate and a backup port. This is a block port. Okay. So in here, as you can see that we have a port 01, FA01, which is a designated port. And then you have FA021, which is this one. FA021 is an orange color. This is called an alternate port or a block port. Okay. And we have FA024, which is root port. Root port is the one that is going toward the root switch here. This is the root switch. So it's the closest one to the root port, to the root switch. Okay. So don't get confused with this port role. You have a root port, designated port, alternate, and backup port as a block port. Alright, the next one. The next one is switches send and receive spanning tree frame called BPDU, or Bridge Protocol Data Unit, at regular intervals. BPDU is a data message transmitted across LAN to detect loops in a network topologies. BPDU contains information regarding ports, switches, and port priority and addresses. BPDU contains the information necessary to configure and maintain spanning tree topologies. Okay. Active spanning tree topology of a switch network is controlled by the following elements. I will refer you to this website again. If I scroll it down, the first one is the unique bridge ID, which consists of a switch priority and a MAC address. Okay. Then the spanning tree path to the cause. The last one is a port identifier, which consists of a port priority and the MAC address. I have a sample here. If I scroll it down, okay, if I go to show spanning tree protocol, notice that this is the bridge ID. The bridge ID consists of a priority and a MAC address. The default priority is 32768. This is 9 because we are in VLAN 1. So the default priority is 32768 plus 1. This becomes 69. Okay. The cost of that, the cost is, we need to calculate what is the closest to the root bridge. That is the cost of the spanning tree protocol. And the last one is a port ID. The port ID is this one. If I scroll it down, you see this port ID. The default is 128, and this is the MAC address. Okay. Therefore, so active spanning tree topology is controlled by this one: the unique bridge ID, spanning tree cost to the root switch, and the port ID that consists of port priority and the MAC address. If I show you on the configuration here, you can see that, okay, this switch is not, okay, this switch is a root switch. How do I know that? If you can notice that this is the MAC address is the same. The root ID and the bridge ID has the same MAC address. Then I know this is a root bridge. Also, if you notice that the port rows, all the port row is a designated. That means this switch is a root port. This is a root bridge. Now, if I scroll it down, if I run this command show spanning tree, notice that this is not a root bridge. Why? Because as you can see that the MAC address on the root ID and this one is different, and the bridge ID. So this is not a root bridge. If I look at the bottom, the port row, they are not all designated port. One of them is a root port. So this is not a root. This is not a root. Okay, I want to mention the last thing. Actually, I want to mention something that the spanning tree protocol, this is how you calculate the cost. Okay, if you are in the 100 megabit Ethernet, the cost is calculated as 19. Okay, if you are on the 1 gigabit Ethernet, the cost is 4. Okay, and the 10 gigabit, the cost is 2. Okay, so if let's say that this port is a gigabit Ethernet, this one has the lowest cost. Okay, remember, gigabit, as you can see in here, gigabit, the cost is 4, right? So this is gonna be 4, right? The cost is 4. So this one, which is gigabit 02, this will be the root port because it's the lowest cost to the root bridge. Okay, this is FA Ethernet, which is 100 megabit per second. FA02, FA023, FA024, this is just 100 megabit per second. So the cost is 19. Okay, that's how you calculate the cost to the root bridge. Which one has the lowest one? That is where the route goes to. So I just want to make an overview again. This is a designated port, this is an alternated port, and this is the root port. The root port is the closest port that goes to the root bridge. Okay. One thing that I want to mention also, you have to, if you run this command, if you run this enable config T, and then you can go to show spanning tree summary. Okay, wait, where is it? Exit, show spanning tree summary. It show you the summary of it. Alright, it show you all the information about that. Okay, thank you. We hope that this information is good to you. Thank you.